In this presentation, we'll just go over those practice problems from the third group that I've given you. So I'm going to move a little bit quicker through these now that we've done so many of them, just so I don't tie up all your time just looking at each slide. So remember, uh, what we do is we take our premises. We've got two here. We'll list them on the left-hand side of the line. And then we'll take our conclusion and put it on the right side here. Put not M. And then just use our rules. So, for the first one up here, I'll start using the colors again. I forgot about doing that. We're going to start with that one. So the main operator is a double arrow. So double arrows, we branch out. And since we're saying it's true, that means that either both sides are true or both sides are false. And then we just need to break down these wedges. So what makes a wedge true over here is if one of them is true. What makes a wedge false is if they're both false. So that breaks it down as far as it will go. Now we're going to look at this one here. So what do we do with arrows? Well, we break those apart too. I do them all on each one of our branches. And what we do is put the left side as false and the right side as true. It's P and M, P and M, P and not M. So the T is as simple as it will go, but we still got to break down these ampersands, and what makes an ampersand true is if they're both true. So put P here, not M below it, P not M, P not M, and then we just need to flip these M's across the line to get rid of the tilde. Then that one is all done. And then the last thing we gotta do is just put these, or flip this not M across the way on all these branches. That's good. So we'll just take this not M and just turn it into a regular M on all of these branches. Now that's done, and so we will move on to looking at the different branches to see if we can find any contradictions. This first one here, I don't see any. Second one, I've got the M, the M. This one, I've got the two T's. This one, I've got the M and the M. Nothing there. And then M there. So since we have at least one, in fact, we've got two open branches, this is invalid. And since it is invalid, we need a counterexample. And for our counterexample, we need each letter. So we've got P, S, T, and M. P, S, T, M. And I'm just going to look at this first branch all the way on the far left here. So I'm going to look at this one, and I can see M is on the left-hand side, so that'll be true. T is on the right-hand side, so that's false. S is on the left-hand side, so that's true. And P is on the left-hand side, making it true. So there is the first one. So again, just moving a little bit quicker on these now. Let's just take our premises that we've got up here. list them on the left side of the line, and then we're going to take our conclusion, list it over here, and what we want to do is just start with this first premise. So I'm going to look here, and the main operator is this tilde because it's operating on this whole thing. We could see by the parentheses. So I'm going to take that, I'm going to flip it across. QT. Now we've got a wedge as the main operator. So what makes a wedge false is if they're both false. And then we've got to flip these across. I'm just going to put them directly across because I'm going to need the room. I know that already. And then we just have this Q and T. So that breaks this one down completely. And just to show you, so we've got all this, and we got this. This one comes from here, this one comes from here. So I know I did that one pretty quick, but that's everything that's going on from those different steps. So now we got that one. Now we've got an arrow. And an arrow on the left-hand side says that this or this. Antecedent's false or the consequence true. Left side's false or right side's true. So that's all we have to do for that one. So that one's done. Now we just need to do this double arrow. So what makes a double arrow false is if they don't match. So this is going to be pretty long. T. Q. So again, these are just not matching sets. Same thing in both branches, but the idea is that for a double arrow, what makes it false is that they don't match. So both possibilities are listed there. Now we just need to break down these ampersands. And what makes an ampersand false is going to be if one of them is false. So either not S or T. Same thing's going to happen over here. And then what makes it true is if they're both true. Like that. Now I just need to flip these not S's over. So this one will go there. 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 So now we've broken everything up for that. And we just want to go back through, see if we've got any contradictions. Well, I've got an S and an S here. And in the next one, I have a T and a T. And then I have an, erase these other circles. In this one, we've got an S and an S. In this next one, SQQTS. That looks open. So that one's open. Here we got a T on both sides, so that one's closed. Then we've got S on both sides, so that one's closed. So remember, when you go to check for validity and checking to see if anything closes off, you're just going back up through the branch like this. So you're starting from the bottom and you're working your way up when you're trying to figure out if there's any contradictions. Start from the bottom just like a maze and then go all the way back up to the top of the truth tree, and that will tell you if there are any contradictions. So we do have one open branch, this branch right here, so that makes it invalid. Now list a counterexample. Our counterexample needs S, Q, and T. And in this one, we've got an S on the left-hand side, so that makes it true. We've got a Q on the left-hand side. That means Q is true. And then we've got a T on the left-hand side, which makes that true. So that is the second problem. I'll try to remember to color code the premises on this one like I have been doing. The past two I forgot to do it, so I'll try to do it here. It's a T. And just P by itself. And then, so let's start with the first one up here. What's the main operator? Main operator is the arrow here, because we have this side and this side. So what's the arrow tell us? The arrow tells us to split it up. Put the thing that's on the left hand side here. Put the thing that's on the right hand side here. And then we just need to flip this across. Get rid of the tilde. Then with an ampersand on the right hand side, we're going to branch that. Put each of them on one side. Now we've gotten that one broken down as far as it will go. Let's look at this one now. What's the main operator? Well, I have this is one side, this is one side, so it's got to be another arrow. I got to do this in all the branches. So same thing's going to happen as before. The left side is going to go on the right hand side of these lines, signifying that it is false, and then the right hand side is going to go here. Then we just got to flip these T's across. And now we're done with that one. Then we just need to go back through, because our conclusion is just the letter P by itself, and look to see if we've got any contradictions. This first branch, I don't see any, so that one should be open. Here I've got the two different P's. I've got a green P and a red P. This one is open. I don't see anything that cancels out. This one will be closed because I got a green P and a red P up through the line. And then I got T's that cancel each other out, and same thing with the P as before. So since we have open ones, this is going to be invalid. We're going to have a counter example. And we have P, S, and T as our letters. So here we'll just go back through up our open branch, and we see that there's a green T, so that means it's going to be true. It's on the left hand side. I got a P that's on the right hand side, so that is false. And then if you remember from previous lectures where I've told you that if a letter doesn't show up, then that means it doesn't matter what its value is. It could be true, it could be false. It's just saying that this is invalid regardless. And so here we could put either true or we could put false. We just have to pick one of them. In this instance, you could have looked at this branch instead, and you would have seen that there is a value for S that's false, but both of them would have worked in this instance because S really doesn't have a bearing on this branch over here. It's invalid regardless of whatever S is. So, but again, doesn't matter. You could have listed either or. So that is problem 3. Now, for problem 4, taking our premises, putting them on one side, taking our conclusion, and on the other side. So starting with this one up here, main operator is that first ampersand that's outside of the parentheses. So I'm going to stack them. Then I still got a new or now I've got a different ampersand that's on the left hand side of the line, so I got to stack those. So these two come from this. Then we've got that one done. We've broken everything down. Now we got to look at this other one. Main operator is the arrow, so arrows we branch out. Take the left hand side, put it on the right hand side, take the right hand side, put it on the left hand side. So what do we do with an ampersand on the left hand or on the right hand side? Well, we split it up and then put either or. Either the left hand side's false or the right hand side's false, so that one's broken up. I gotta flip this T across here. Then that one is all done. Oops. With authority, that one is done, I guess. Now we just need to look at this one. So what's the main operator? The main operator is a wedge. So if a wedge is false, we stack it. So we gotta stack it on each one of these lines here. So both of these have to be false. So not T. I picked orange. Not T. And then S double arrow R. Not T. S double arrow R. Not T. S double arrow R. I'm going to just flip these T's across like that, getting rid of these tildes here, so these are representative here. And again, this everything that we just did is tied in here. That's why they all look the same, because we had to break the conclusion down here in the lower levels of the branches. Now we just have to take care of this S double arrow R. And to do that, we got to branch out. And we just have to make it so they don't match. S on one side, or on the other, same thing on all of these. S. So remember what makes a double arrow false is if they don't match. Now we've broken everything down into the simplest parts. That's all done. Let's go back through, see if we've got any contradictions. Looking at this first one. Using green. I thought I was using blue. Let's see. RST. Nothing there. Looks like it is open. Now, this one I see is closed because I've got R here and an R here. This next one, I've got an S here and an S here. So that one's going to be closed. RSTSP. This next one looks open too. Let's see. RSS. Nope, we do have a one that closes off. We got an S up here and an S right there. So that one closes off. Then we have, actually I know this one's, all of them are going to close off because I've got these two T's here. So as I go up through this one, I'm going to run into those two T's there. As I run up through this one, I'm going to run into those two T's there. So they're both going to cancel out because of that. Now I do have an open branch, so this is still invalid. And I need a counter example for it. And I've got, let's see, Q, R, S, and T. So Q, R, S, T. So going back through, I have an R on the right hand side, an S on the left hand side, T on the left hand side, that is an R, not a P, and that does have bearing. Sorry about that. See, this is why you double check from time to time. So that should be an R. The fact that that's supposed to be an R changes that this is valid. Always good to double check. I'm not going to re-record this one because this is a pretty good teaching point, and that sometimes these things can get very confusing. Well, how about involved? I guess they don't get too confusing as long as you remember to follow the rules. But as you just saw, that R does make this one close off. Oops. Because I didn't have this and this. So if you caught on earlier that I screwed that up and put a P instead of an R, you probably knew that I was going to be in trouble by the time I was done with this. So this one is valid. They all do close off. And so that is the fourth problem. Moving on to the fifth one. Put our premises here. Put our conclusion here. Start with the first one. The first one is a wedge as the main operator. So for our wedge, we just split it up, mark them both as true. Then we have an arrow here. And what we do for an arrow, same thing as always. Left side goes on the right hand side goes on the left hand side of the split. Then that one is all done. Let's look at this next one. The main operator here is the ampersand, so all of these are going to get stacked on top of each other. So we'll have a not T, not R, not T, R, T, not R. Need to flip all of these across. T and R, R, T and R. And again, for those of you who see it already, you could go ahead and close off these two branches and stop doing anything because they're going to cancel out no matter what. Anything that happens down below here or down below here is going to cancel out because they run into those. But again, you don't have to do that. I just flagging it in case you see it and you're like, okay, I don't want to have to break these other things down below here, but just so you know. So the last thing we got to do is flip this across 2 times. So here's the first time. Then we just got to flip it across again to get rid of the other. Like that. So as I already said, we know this one's going to close and this one's going to close. And then we just have to look back up through here. This one doesn't close because we have all of our different letters on the same side. There are no red and green pairs, so that is invalid. The counterexample would be STR, and they all look false. They are all red. Again, where I'm getting those from is the fact that they are right there in the truth tree. Going back up through, since they're on the right hand side, they're false. If they're on the left hand side, they're true. So that is this problem. Now, on to the 6th one. Same thing as all these other times before. Make sure I get that tilde in there. Then E and S or T. Not S. So first one, our main operator is the arrow. So arrows we split apart. Put the left hand side, oops. Put the left hand side here. Put the right hand side here. Now we just gotta do more stuff to this one over here. Just gotta flip it across to get rid of the tilde. Then we're going to have to branch out. I'm gonna extend this branch just in case. I think I might need to. And then we just have to make sure they don't match. So we'll put an S on this one. We'll put a not T over here. Put our T here and put our S over here. Then we just need to flip this T across both sides. And that is it for that one. And then we just want to do this next one. Main operator here is an ampersand, so we gotta stack these down. P, S or T, P, S or T, P, S or T. Flip this P across to get rid of the tilde. And we want to split this S or T apart. So that we have one of them is true. And then that should be everything for this one. Then we just need to take care of our conclusion, which is going to just flip it across. Here. So all those S's are coming from here. That's why that S goes there. We're flipping across the tilde to get it to on each of the branches down below. I know that looks a little bit weird, so I just want to make sure we're on the same page there. So let's go back up through. I don't see anything that closes off here. I don't see anything that closes off here. Not seeing anything that closes off here. Nothing closes off here. Do have these S's here. S there, S there, S there, S there. So those two do close. But it's not going to matter because we got these other ones that are open. So this is going to be invalid. I have a counter example. And then we're going to have P, S, and T. I'm just going to look at this one right here. So this is another instance in which I don't have the value of T. I've got S's that are true and P's that are false, but I don't have a T. So I could put either or. I'm just going to put true because I see this one here. I could use that one just as well, but it doesn't matter. So again, if you come across a branch that doesn't have a value for the letter to put in the counter example, what you're going to do is just supply either a T or an F for it, because it has to be one or the other. It has to be either true or false, but it really doesn't matter which one it is. So if it's ever absent in a branch, just pick whichever letter you want to, either T or F for it, and then you're in good shape. But that is the sixth one. So let's just do the same thing as we've been doing before. Put our premises here on this side. T, S, M. Starting with the first one, it's just got a main operator as a tilde. It's operating on this whole thing. So we just have to flip it across. The main operator now is a wedge. So what makes a wedge false is if they're both false. And then we still have this wedge right here, so same thing as before. Just gotta stack them. What makes a wedge false is if they're both false. And now we've got that one all done. Moving on to this one. This one's main operator is an arrow. And for an arrow, same thing as we've been doing. Left side is false, right side is true. Then, to break this one up, we just have to stack them. Breaking up this ampersand just gets us to the M and S. And then we've already got an M by itself as our conclusion. So let's just go back through. I don't see anything that closes off in this branch, but I do have an M on the left hand side and on the right hand side. So that one will close off. Then, since we do have an open branch, we know it's invalid. We have counter example, and we have S, Q, T, M. Going back through, I see a T that is false, I see a Q that is false, I see an S that is false, and I see an M that is false. Again, we're just going back up through this branch, and we're looking at which side these letters are on. So that is problem 7. Now, on this one, it looks like we just have one really long premise. S, T. Three parentheses there, yep. And then we have not Q and S. And now I know that this premise looks really confusing, really large. But remember, it's just a step-by-step process. Let's look for the main operator. The main operator here is the arrow. So, same thing as we've done with all the other arrows. Just take the left-hand side, make it false. Take the right-hand side, make it true. There. So, let's try to read this. Not T Q P O S. And I still need one more parentheses. Now we just need to flip that across because the main operator here is a tilde. P. So now we flip that one across. What makes a arrow false is if the left side is true and the right side is false. Opposite of if. So remember, when we do an arrow on the left-hand side, we branch it apart, and it's the left side's false and the right side's true. Here it's the complete opposite. It's the left side's true and the right side's false if the arrow's on the right-hand side. See? Left side here, and we stack them. On this first one, take that, and it's false. It's true here. So just remember that all of these rules, if they appear on one side, they're one way. If they appear on the other side, it is the exact opposite of what you do for it. So now we still have this ampersand. What makes an ampersand false is if either side is false. Q, Q, or S. Then we still need to do this one here. So what makes a wedge false is if they're both false. Like that. And then we just need to do our conclusion. So first thing we got to do with our conclusion is flip it across. S. Q, and S. And then we just have to stack them because the main operator is an ampersand. Q, S, Q, S, Q, S. And then we just need to flip these Q's across to get rid of the tilde. And now we're all done with that conclusion. So we can go back through. First one, I've got S's on both sides, so that'll close off. I have, let's see, nothing that closes off here. So I got an S on the left-hand side, Q on the right, T on the left. Nothing closes there, but I do have S here, so that one does close. Now, since we have an open branch, it's invalid. Do a counterexample. I've got S on the left-hand side, Q on the right-hand side, T on the left-hand side, and I'm missing P, so P, Q, S, T. So Q was true, or sorry, S was true, Q is false, T is true, and I don't have a P anywhere, so it doesn't matter what I put for it, so I'll just put true. Just have to put a value for it. That is problem 8. So, same thing as before. Premises on the left-hand side. P Looking at this one, main operator is the wedge. Wedges we break apart. And we put both of the disjuncts, or both of the sides. Disjuncts is the proper logic locution for wedges, in case you hear me say it again in the future. So we put both sides on each one of these branches is true. Let's look at this S and T. This S and T is true, which means we have to stack those. Then main operator here is also an ampersand, so we'll stack these. Then we just have this other wedge that we have to do something with. We have to break it up into those. And so that one is all done. Now we just got to do our conclusion. Conclusion is a false arrow, so we need to put it as the left side is true, right side is false, and then we just have to flip those across to get rid of the tildes. Now we can go back through, and it's not looking like I've got anything that closes off there. Nothing will close off in this one either, and nothing closes off here, so they're all open. So this one will also be invalid. Counterexample. So we've got P, Q, S, and T. P, Q, S, and T. Just gotta look at this one right here. I've got a Q on the left-hand side, T, S, and P. They're all true because they're all on the left-hand side. Q, T, S, P. So that is problem 9. Last problem in this problem set. So we've got, looks like 2 premises. And a little bit far off from the line, but it'll be alright. Q, double T. So, first premise, main operator is a double arrow. Double arrows, we branch out. And if it's true, then they are matching. Either they are both true or they are both false. P. Looking at this one here, so to break up this ampersand, just stack them. And then we got to flip this tilde P across. And if we're looking at this negated, false ampersand here, false ampersands, you split them up, put them like that. And then we just got to flip this P across. Now, that one's all done. Now we gotta look at this one. Main operator here is the arrow. So, not S, not S, not S. Put the T double arrow Q, T double arrow Q, T double arrow Q. Flip the S's across to get rid of those tildes. We gotta break up these things. And remember what makes a double arrow true is if they both match. So either they're both true or they're both false. Now, to do this last conclusion, it's going to be a little difficult to do because I'm running on route. Should be able to make it work. So, what makes a double arrow false now that's on the right hand side is if they don't match. So Q on one side, T on the other, Q on one side, T on the other, Q on one side, T on the other, Q on one side, T on the other. Same thing, same thing. Just gotta go back through, put the other letter on the other side. T, Q, T, Q, T, Q. Oh, I forgot to do one right here. And there. This one got really branchy by the time it was said and done. Do it. Of these. Q, T, Q, T, Q, T, T, Q, T, Q, T, Q. This would be one of those instances in which you might have wanted to close off branches earlier on, so you don't have, what is this, 2, 4, 6, 8, 10, 12, 14, 16, 18 different branches to go back through and look at. But it'll be alright, because again, as long as you do everything by the rules, you are in good shape. Doesn't matter what it looks like. You could have 100 of these branches. Hopefully I will never give you one that is that difficult. In fact, I know I won't ever give you one that's that difficult, but this one turned out to be pretty wide. So let's just start on this one. Move up this way. So I've got a QTSPSP. So see, I've got a P and a P here. So everything that's going to come from those two are going to be closed. So I know that all these branches are going to be closed off. The reason why I know they're going to be closed off is because I have this thing all the way up here. Really, I could have stopped and wouldn't have had to do any of this other stuff up here if I would have noticed that I had those two right there. But again, doesn't matter how you do it. You could do it the way that we've got it on the screen right now, or if you want to put an X there to make your life a little bit easier, that's totally fine too. So now we know that we've got all of those done. So now we got, so all of those branches are done. Now let's look back up through here. I see that I've got an S and an S on both sides there. So that will close off this one and this one. Next, I know that I have T here, T here. So that one will also close. Here, I've got a Q and a Q. Q and a Q. So that one will close. Then I have Q and a Q here. And then a T and a T here. So those will close. Now we're done. Oops, I meant to use orange. Now we're done with that. And here, I know all of these are going to close because I saw this earlier as I was doing it. I've got a P and a P here. So everything's going to close off down below on all of these, because everything's going to get closed off due to there being that contradiction up here, close or further up on the truth tree. Again, you could have just put an X here and you wouldn't have had to do any of this stuff down here, but for the interest of just keeping consistent, I went ahead and did all of it. So this one, all of them close, which means it is valid. No counterexample needed.